The last time we met, we created esters. We started off with some yuck, putrid, smelling things. Hopefully you guys didn't smell too much after that lab. And then we created some good smelling things. Some of us got a banana, pear, wintergreen type of smells. So we are going to look at lesson 7. Hopefully this helps you finish up your lab analysis and your conclusion. And also it'll bring us into lesson 8. Lesson 8 is a really good explanation of lesson 7. So our discussion notes start of what is synthesis. These are the discussion notes for lesson 7. Just kind of write these down on the side of lesson 8 notes. But the synthesis is basically a creation of something new. If I ask you what something is synthetic, we might say that a synthetic material is something that is created by a chemist or some kind of scientist. They're making a fake of something. What we're looking at is that we started off with 2 chemicals that had distinct smells. The alcohols really smelled kind of sweet, and the carboxylic acid smelled a little bit putrid. When we mix those together, we had a chemical reaction occur. If you look at the purpose of the problem of our lab, it is stated on the formal lab report that we are trying to determine a chemical reaction occurs. If you look at the very last statement here, 2 molecules with their own unique smells can combine to produce a new molecule with a different smell. That was our main purpose of what we did in the lab. Now we start the notes for lesson 8. The discussion notes talks about a chemical equation. A chemical equation is a chemical sentence that tracks what happens during a change in matter. So this change in matter here on the side, I will underline it for you. That right there, that change of matter is the point that you guys are going to fill in. Get that in red so you can see that. Chemical equations are written with chemical formulas. We know, we've seen chemical formulas, and they keep track of all the atoms that are involved. Okay, so we look at a chemical equation. When I look at a chemical equation, it is something as simple as taking an element A, let's say, an element B, and we smush them together and we get element A, B. Some of the chemicals we used in lab. We used the chemical acetic acid. That was that really smelly kind of vinegar smell. It is vinegar. We used it with a sweet smelling alcohol, and before we got putrid, we ended up with that banana smell. And I know that's one that we created very well done. Again, if I was to write this out, here you have your element A plus our element B, and it gave us element AB, or compound AB. We talked a little bit about functional groups. Functional groups are groups that give function to the molecule. Here we were dealing with an ester group. An ester functional group is something that was represented with a C double bonded oxygen followed by an O, and it's in the middle of the molecule. So this here is our functional group, and this gave us that sweet smell. So we're taking acids plus an alcohol, and we were getting an ester. Let me show you in the next slide that reaction. Here is an example of what we did in lab. We took our acetic acid and we mixed it with butanol, and we got something called butyl acetate, which is more of a sweet smelling thing. So you have your OH group, so here's your acetic acid. We have our OH group on the end here. And like a puzzle piece, it gets torn off, and you can see that it got torn off and put right there. Then on the end of the butanol, which is the alcohol, we took this hydrogen, gets torn off and put here. Together, you get H2O, 2 H's and an oxygen, forms water, and your leftover pieces, and I'm going to highlight those leftover pieces here in red. Your leftover pieces, which is this one here, and, let me get that oxygen in, and this one here, they come together. When those red pieces come together, we get our new ester, and this is our ester. So you have your acid and your alcohol is forming our water and our ester. But this right here, what I am circling, was very important. This is the stuff I gave you. This was the concentrated sulfuric acid. Without this, it would have taken us so long to do this lab. Let me explain. When we're talking reactions, we have two different things. We have the reactants and the products. And a reactant on your notes is an element or compound that is the starting ingredient. Like if you were cooking, this would be your sugar, your eggs, your water, whatever's going into that recipe is your reactant. Okay, now on the other side of the reaction is going to be the product, an element or compound that results from a chemical reaction. If I write this down, I would have my reactants are on the left side, and they yield, or the arrow, to the products, and the products are on the right. The products is like the cookie that I'm trying to bake. Sometimes reactants to form products take a long time. There is something called a catalyst. Catalysts are used to speed up that reaction, to accelerate a chemical reaction. They are not consumed, meaning that they're not part of the products, and they don't alter the reaction. All they do is they speed up a reaction. A catalyst is written above the arrow. So if we look back at your notes, and I said that we had the catalyst was the acid. I was the catalyst. I was used to speed up that reaction. I think of a catalyst like when my sister was dating and I was trying to set her up with somebody so she could get married. I was the catalyst. I was trying to introduce her to somebody that she could form a relationship with. I was not part of the relationship. I was just trying to speed up the process. That is called a catalyst. You're not going to have to know too much about how to name things, but I just wanted to show you how it is all related. If I have formic acid is actually what's found in bee stings, so if you're allergic to bees, that's where it's coming from. Formic acid, that part of that word becomes part of the end of the actual name of the product. So here you have the reactants of formic acid, and they form the product. So we have the reactants. Formic acid reacts with octanol. We can see that the word oct comes to the product, which is called octol, and then the formic becomes the formate. So we have the reactants forming the products, oxyl formate. This would be a great conclusion to our lab lesson 7. What happened? Well, we had individual smells. We had individual smells of the reactants, and when we mixed them together with a catalyst, we formed a new product. And there was evidence of a chemical change because they formed a different smell. A new smell was created. In chemical reaction, bonds are broken and new ones are formed. And those new ones told us that there was a new smell. Okay, to finish it up, the check-in question of the day here. If I pull off this H, and I'm going to pull off this OH, we have an acid with an alcohol is going to be a product of water. That's one of our products. The other product, stick the rest of the pieces together. I have an H, C, double bonded O, O, C, H, C, H, 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 H. Okay, and we form something new. These are the two products that we would get. Again, just to look, let me circle it in green for you here. You have your water comes in, forms this, and this. I put them together, and I get my ester.